Hi. So you heard a lot of edge AI, you heard a lot of cameras. Now we're going a bit deeper into a camera. What do you need to put behind the sensor to do some image processing and all this stuff? And this is where you usually can use FPGAs. What is the benefit using FPGAs compared to microcontroller, microprocessor? An FPGA can do things always in parallel, where a microprocessor can do only step by step everything in series. And therefore, FPGAs are very common in these camera applications. Some words about Efinix. So we are an American-based company, and we have our headquarters in Cupertino, just around the Apple Circle. We have development locations in Toronto, Penang, and our headquarters here in EMEA is in the north of Munich, and we have as well an application office in Manchester. This is important because you have to make sure that you get the support you need if you develop an FPGA. FPGA companies are around here since more than 40 years. But as well, they are using the same architecture since 40 years. If you look at the right-hand side or left-hand side from your side, they usually have fixed logic blocks, fixed routing. Especially routing is important in an FPGA because you do not know where your design is placed on an FPGA, and therefore you have to provide a lot of routing to your FPGA that you guarantee a connection from A to B. This ends up in a very large die because you need this high amount of routing. We solved this problem in our quantum architecture. What is the difference? We have our cells, our exchangeable logic and routing cells, which can handle both logic and routing. Means with our architecture, we can provide routing in the area where it is required. So we have not to have all these huge routing resources in our chip because we can place a routing where we need it, and our cells can do both logic and routing, and both as well at the same time. And this will end up in half of the die size to a comparable device from maybe the market leader, and as well lower power in dynamic, but as well static power. And this is cost optimized because at the end you have a die size, and this is usually the base of a cost of a device. And very important is that we are silicon process agnostic. Why is this important? I think we all remember 2-3 years ago we all had these problems to get silicon devices, and at this time with our architecture we were able to deliver the goods to our customer with less than 20 weeks lead time because we did not have special requirements on the silicon process. So we are taking the process parameters from the process manufacturer, putting it to our FPGAs, and done. And then they can put our lot into a high running scheme without interrupting the performance in this. And therefore, we were always able to deliver our goods as well in the rough time. What are our FPGA families which you can use for connecting the sensors to the FPGA, but as well putting your output out from the FPGA? We have the Trion FPGAs, which is based on a 40 nanometer SRAM process. And so it's a standard FPGA, mainstream FPGA, which can be used everywhere. But important for the camera application is even this FPGA can handle 1.5 gigabit MIPI interface, which is important for the sensors. Then our titanium family is based on a 60 nanometer process. And this guy can handle up to 2.5 gigabit per second on a MIPI interface for MIPI CSI and DSI. And we implemented a low-power DDR4X memory controller that you can store as well your frames if you would like to manipulate them or you check them out. And we added as well high-speed SerDes to the FPGA that you are able to handle on your camera 10 gigabit Ethernet. You can handle PCI Express, you can handle Co-Express, CP12, or all these high-speed interfaces which are required for the camera applications. As not everybody needs 16 gigabit SerDes, we have as well a more cost-optimized version, the Topaz family. This goes up with a SerDes speed up to 12.5 gigabit, which is still good enough for our 10 gigabit Ethernet camera, and as well supporting you with low power DDR4 memory controller and the MIPI interface up to 2 gigabit per second. All the families can be designed with our Affinity tool, which is free of charge. Means you can register on our web page and you have access directly to our software. Here an overview, especially for camera or vision applications, because what you are looking for, MIPI interface, what is the speed, so depending on your sensor. Here an overview, what is Trion providing you, what is Topaz providing you, and Titanium. Important as well, the memory interfaces, and we choose LPDDR4 or LPDDR4X because this gives you as well the power benefit which is usually required in a camera application. For computing, if you need some microcontroller inside, we are focusing on RISC-V based processors. So that means we are supporting RISC-V processor in all our family on a soft IP core base. So in Trion, it runs up to 120 megahertz. In Topaz, up to 250. In Titanium, up to 350 megahertz. Still a soft processor. In Titanium and Topaz, we added as well to the devices which are supporting high-speed SerDes and hardwired quad RISC-V core, which is able to run at 1 gigahertz. And this is good enough for a lot of applications. But the big benefit for you is, so we did some measurements. We had running a core with 4 cores at 1 gigahertz, and we are roughly consumed 500 milliwatt. And if you compare this to other applications, this is a big benefit. And power consumption or the related heat you are generating in a camera, it's not necessarily a friend of you. An additional application we have here for special cameras is our TI-60F400. We are calling it a SIP, System in Package. What have we done? We added to a 60,000 logic element FPGA a HyperRAM module with up to 256 megabit on memory, and we added a SPI flash into the same package. Means now you have a package 5.5 by 5.5 millimeter, which contains a 60,000 logic element FPGA, the related SPI boot flash to it, and a 256 megabit HyperRAM, which you can use maybe for your processor or store a frame from your camera in this application. All the standard high-speed IOs are able to handle 1.5 gigabit MIPI, and we are supporting as well MIPI by 8 if you need a wider MIPI interface. What is the benefit of using Efinix in your FPGA or in your camera design? I think what we are focusing is really to focus on the customer, not necessarily on the money, because we are still a private company and not a public company. Therefore, we have the benefit to set our goals and therefore try it out. always the feedback we get from our customer that the support is really outstanding. And because of our architecture we have, the quantum architecture, we are able to do really small die sizes in our FPGAs. For example, a package 3.5 by 3.4 millimeter with 60,000 logic elements. Try to find this somewhere else. And in the same time, if you have such a small die, you must be able to have low power, because otherwise you will not get the heat out of the system. And then the package I already mentioned, the 5.5 by 5.5 millimeter as a system in package. This is as well only possible if you have small die sizes and a low power consumption. Otherwise, the package would burn out because you have additional power consumption from SPI flash, from HyperRAM, and then the additional 60,000 logic elements. Our FPGA is supporting LVDS interface you need usually for the sensor interfaces. MIPI always depends which you are using. We are supporting as well SLVS EC interfaces for the higher end sensors, and USB 3 with the different FX solutions from Infineon. Ethernet 1 to 10 gigabit, not a big deal, and PCI Express up to Gen 4. So usually everything you need for your camera design, or as well frame grabber. Important as well, especially for our customer, is that we are delivering our software free of charge. So you do not have to pay something. You do not have to request a license. So you are registered on our web page and you have access to our software, install it, and it's working. And everything is proven in use. Check around here some camera vendors. Very often you will find Efinix as their FPGA solution. Even go to the Infineon booth for all this FX10, FX20 stuff. You will find our devices which they chosen as their eval platform. I mentioned already that we are focusing on RISC-V as our soft IP, RISC-V as well hard IP. So we are offering here Sapphire SoC. This is our standard RISC-V soft IP, which goes up to 350, 400 megahertz. So must be a marketing fault with a 400, more 350. And even on this soft IP core, you are able to run Linux on it, because we are supporting as well an MMU and an FPU for this kind of processor. If you say, RISC-V is nice, but I do not need such a big system, we are supporting as well a Sapphire Lite. Just if you need a controller which is putting some register here, some information there, then we are offering you a 4K logic element soft processor, RISC-V based. And then our high-end, the Sapphire high performance SoC. And this is in all our FPGAs which has high-speed SerDes included. So with this, we have a quad RISC-V implemented, which runs up to 1 gigahertz. And not important the speed, but the speed and the power. So we are in the 500 milliwatt area if the 4 cores are running at 1 gigahertz. And this is really outstanding in the market. Usually you need additional IP cores for your FPGA generation. And therefore we have our IP manager where you can find all the other IP cores which are required from some memory stuff, FIFO or block RAMs. We have the whole MIPI interfaces there. We have a triple Ethernet max spec. And now I think with the next version which is coming out end of the month, we're adding a 10 gigabit Ethernet MAC to it. All the cores you can select, specify the core, and it gets generated. And all the cores you will see here belonging to the software. As the software is free, the cores are free as well. To do a proof of concept of your product, you can use as well development kits. Here a list of development kits for our Trion family, for our Titanium family. Our latest board which is available is a TI 375, so it's a titanium with 375,000 logic elements and has 16 gigabit SerDes channels. And this board provides you a PCI Express finger with PCI Express Gen 4x4. We have this SFP Plus cage for 10 gigabit Ethernet and FMC connectors where you have access of additional 8 high-speed SerDes channels and user IOs. And on the right-hand side, the QSE connectors. Here you can connect our MIPI interfaces up to 2.5 gigabit to it. Here's an example which we are showing at our booth is our TI 180 connected to a MIPI camera with 4 times 2.5 gigabit per second and then connecting via USB 3 10 gigabit to the PC and then showing the picture on the monitor. And if you would like to see the first industrial camera which are handling this, you can go to IDS Imaging. They already have an industrial camera where they are using our titanium in combination with the FX10. Software, I told you already, the software is free of charge. Just go to our web page, to the support page, register, and then you have access to our software. We have a netlist viewer if you would like to see a schematical view of your VHDL, system Verilog or Verilog. On VHDL side, we are supporting VHDL 2008 and VHDL 2019 interface. So really the state-of-the-art standard of VHDL. Then sure, we have a floor plan viewer, interface designer. This is a bit different approach to standard, to the other FPGA vendors. All our IP cores we are providing are in the interface designer. So if you have a PLL, you would like to generate 3 clocks, you are generating the 3 clocks in the interface designer, clock 1, 2, 3, and then the connection is done in the entity top module, clock 1, 2, 3. Done. But then you have all your design in the core design, and all what is vendor specific for Efinix is in the interface designer. Then you have as well access to our SerDes in the interface designer. Just click on the PCI Express or Gigabit Ethernet, and then you can configure all the stuff. And the interface to your core design is an AXI bus. So you do not see all this IP cores which has to be instantiated for PCI Express. You just see the AXI bus, and the configuration is done in the interface designer. Package view as usual and a hardware debugger. So we have not these fancy names as all the others. We are just calling a debugger. You can automatically instantiate this debugger in your design. You can add some trigger points to some signals. If the trigger point is reached, then we are generating a VCD file, and you can see all the internal signals from your design. We have as well a debugger for the SerDes channels, and you can see on the RX side which signals are received without having a very expensive scope, but sure, you can use it as well to do the electrical check. If you do some safety applications as well, the software we have certified. And we are running on Linux and Microsoft Windows. Thanks a lot.